Good morning and good afternoon. In today's lab, we are going to be burning an object and then measuring what happens to its weight. The object we're going to be burning is similar to this. This is a piece of steel wool. You can get it at nearly any hardware store. This is used to scrub things like paint and rust. It's somewhat abrasive. It's not actually made of steel, it's made of iron. The iron has been stretched and drawn into this extremely thin wire, and you can use it to scrub. But it is basically, this is a very, very long, very, very thin piece of iron wire. Now, in order to get it burning, we do need to unroll it and spread the fibers as far apart, and we need to weigh it. So the first thing we're going to do is we're going to place a platform down. In this case, the platform is made of aluminum foil. Next, we're going to take our piece of steel wool, and now we have a weight. I'll give you a moment to record this. So now we're going to burn this. The way we're going to do this is we're going to expose it to a very small electric current in the form of a battery. This is going to burn it up. Now, it's up to you to make a hypothesis. You have one of three choices. After this thing burns, your three possibilities are the weight will not change, so the weight of the foil and the iron will be the same. The second possibility is that the weight goes down, so it weighs less. The third possibility is that the weight goes up. One of those three possibilities must be the case. So let's take care of this. So we're going to let this burn as much as possible. We have a few spots here. So this iron, it's burning. All that means is chemically it's combining with oxygen. So we're going to let this burn. It's going to take a few moments. And then we will place it back on the scale. This video is uncut, so we are doing everything we can to make sure that all of our measurements are as accurate and reliable as possible. So it appears that it's done burning. One thing we may notice is that the texture and the color have changed. It started off as gray and silvery. It now has a slightly blue color. Its texture is very brittle. We'll see that in a moment. But first, let's weigh this thing. So we're going to zero out our scale. And now we have the new weight. Again, it's up to you to determine, did the weight of the steel wool increase, did it decrease, or is it unchanged? So I'm turning off the scale now. One thing to notice also, the texture has now become extremely brittle. This is definitely something I would not want to clean up with because it would fall apart in my hands as it's doing right now. So its physical properties have changed as well. So go ahead and record your results in your lab. Make sure you answer the questions. And if there is anything you do not understand, please feel free to email me. Thank you for watching. For the second portion of our lab, we are going to do a second type of mixture separation. Last week we saw that we could separate a mixture of sand and salt using distillation as well as filtration. Now we're going to use a technique called chromatography. I have here, this is a coffee filter. So some of you You might have coffee machines at home that use coffee filters. They're a little bit rare nowadays. I'm going to cut some pieces out of this coffee filter. So I have essentially what amounts to a small tail, which is going to be placed in this little tub of water. There's water in here. Before I do that, though, I'm going to take this black marker. I'm going to place a dot right in the middle. This marker claims that the color is black. And the dot certainly looks black. But if we run water through this and the water begins to dissolve the ink, we need to see, is there going to be a change? So I have this sitting here. We'll come back in a few minutes and see what happens to the color of the dot. So here we are about 5 minutes later, and again, we should be able to see some changes. So to help us out, let's zoom in one more time. So here's what's happening after about 5 minutes. And we'll come back a few minutes later and see what happens to the color then. Again, here is what's going on with the water traveling through the ink. So we'll let this go for a few more minutes and we'll come back one last time to see the results of our chromatography experiment. What is happening to the color, and more specifically, is this actually a black marker or not? So here is our final view of what happens to the dot when the water is able to run through it. The idea behind chromatography is that certain materials move faster through our solvent. In this case, our solvent is water. Certain materials move faster than others. Because they move faster, they get separated, and we have a good idea of what's going on. So the original question, was this an actual black marker or not? You should now be able to answer that question. So if there's anything you do not understand or anything you would like me to clarify, please feel free to send me an email. Otherwise, please get this data into your lab write-up and get it in as soon as possible by the due date. Thank you very much. Good luck.